Hello, ladies and gentlemen, and welcome back to another APE screencast with your AP Environmental Science teacher, Mr. Stano. And today we're going to talk a little bit about the structure of matter and energy going forward with the next screencast. So I'd like to begin with just looking at the types and structure of matter. Now, most of us are either taking chemistry or are in the process of taking chemistry and have probably picked up some of this along the way through a number of other different courses. But basically, we have elements and compounds, and matter exists in chemical forms as elements and compounds. Okay, elements are basically the building blocks of matter. We see them in the periodic table of elements. All those that are also in the room, we can see that. So those can come together. So when we have two or more different elements to form compounds, it's pretty easy. Okay, so here we have an atom. We can see our protons. Our protons and neutrons make up our nucleus right here, with the electrons orbiting around that nucleus. Then we have ions. An ion is just an atom or a group of atoms with one or more net positive or negative electrode charges, basically based on whether it has more or less electrons to kind of balance out the charge of the protons within the nucleus. So we can see here we have hydrogen ions, which have that little positive symbol next to it. Okay, so it's missing those electrons. Or hydroxide ions, which has got more electrons, giving it that negative symbol. And we can see it with the sodium and the chloride ions also. What we could do is look at solutions where there's an imbalance, or basically a concentration of hydrogen ions. And this will give us a different pH. So we know if things are, we can figure out if things are acidic or basic based on those concentration of hydrogen ions. We know that pure water, right here, it's got the pH of 7. It's neutral. And then basically as we go higher than 7, things become basic. And lower than 7, we're on the acidic end. It's really not much more to it than that. We then also have these compounds or chemical formulas, which are just shorthand ways to basically name compounds. So combining hydrogen ions and hydroxide ions gives us water, basically, or dihydrogen. Combining sodium ions and chloride ions make compounds of NaCl or sodium chloride or salt. We'll go over basic names, and that's really the most for as naming compounds in this class. We won't have to actually name them, but we'll have to be familiar with the names themselves. Then we have organic compounds. This is where it starts to get a little bit more into what we need to know with this class. These are compounds that have that carbon and hydrogen bonded together. So methane is an example. It's actually an exception to it because it's one single carbon with bound to 4 hydrogens, but it is organic. All other compounds are considered inorganic. So it has to be that 2 carbons bonded with hydrogen in order for it to become organic. We have hydrocarbons, which are just carbons bound to hydrogens. We have chlorinated hydrocarbons, which we will talk about quite a bit in this class, which is those hydrocarbons bound to chlorine. Okay. So those are definitely important. And then we also see our simple carbohydrates that we see from photosynthesis and respiration, which they'll come more into effect also. Moving forward, we can take these and then build things like cells. We have our basic eukaryotic and prokaryotic cells. Eukaryotic cells are what we have, plants have. Prokaryotic cells are the basically the cells or are basically bacteria. And just taking a quick look at them right here. The biggest thing is that DNA is not stored within a nucleus. It's kind of free roaming throughout that cell. Versus the eukaryotic cell where it's bound within that nucleus, and then that's one of the biggest things right there. Macromolecules are just large, complex organic molecules. They basically make up everything that we have here, from carbohydrates, proteins, nucleic acids, and lipids. And then moving on to our states of matter. We know most of the three states of matter, or we've seen them pretty common, so solid, liquid, and gaseous. But we also deal with the fourth state of matter, plasma. It's just basically these highly charged positive ions and negatively charged electrons. It's just that moving up in that energy scale. Sun and stars consist mostly of plasma. And we use it in TVs. Okay, we're going to stop here with matter quality because it's definitely a little bit more important, so I kind of want to take the time here. Hope you enjoyed this little primer into some chemistry that we'll be doing in this class, and that's about it. Take care.